My name is Davide.
My name is Jelle.
Zbyszek.
And we'll be talking about reproducible builds in Fedora, where we are and how we got here. So reproducible builds as a whole is a project that started in around 2013 within Debian. And it made progress fairly quickly. By 2017, more than 90% of packages in Debian were reproducible. And nowadays, almost every package is reproducible. And it's been steadily climbing upwards. And part of the reason why this was achieved was thanks to automated rebuilds. Debian invested in infrastructure to be able to do these builds automatically, get signal out of builds of packages, and check when there were deviations and get them addressed quickly. They have nice dashboards, they have nice graphics, they make it easy for people to follow what's going on. As part of this work, they also developed a suite of tools, including DefOscope, that we'll talk about later, that expose differences in packages to make it easier for people to address problems. This effort is coordinated on reproduciblebuilds.org, that over the year became kind of a hub for this work in other distributions as well. Should probably talk about what reproducible builds is in the first place. So the official definition from reproduciblebuilds.org is that a build is reproducible if given the same source, build environment, and instructions, anybody can recreate bit-by-bit identical copies of all the artifacts. Makes sense. You start from the same inputs, you want to get the same outputs reliably. Within Fedora, we used a slightly modified definition that came up while we were working on this, where given the same code, build environment, and build instructions, and metadata from the artifacts, the idea is that anybody should be able to recreate copies of the artifacts that are identical, except for signatures and part of the metadata. We do this because in our world, RPM embeds things like signatures within the packages themselves, and the signatures are dependent on the bits that came before them. It's kind of pointless to want to have bitwise reproducible signatures because they don't impact anything for the binaries themselves. So that's why we use this modified version of the definition. And we believe that this achieves functionally reproducible builds for us, and it's been working all right so far. Why should you care? There's generally two angles that people look at this from, the security angle and the quality angle, and different people will care about different things. I personally care more about the quality than the security, but they're both relevant. From a security standpoint, if you have reproducible builds, you can have multiple parties doing these builds and checking that the artifacts all look the same so that they haven't been tampered. So this can give you supply chain security guarantees that you may want to have. It can also help addressing the trust in trust problem, where if there's a compromise very early in the build chain of an environment, that can propagate down and become undetectable down the road. From a quality standpoint, sometimes hardware fails, sometimes hardware can introduce bit differences because of cosmic rays and fun things like that. And reproducible builds are a great way to get this surfaced quickly. It can also surface build system misconfiguration issues where if builds are ran, say, on builders of different architectures, they can have subtle differences that don't impact day-to-day functionality, except when they do. And then it surfaces bugs, both bugs in the software itself and bugs on the packaging side, which we want to fix.
So, does this work? Davide mentioned that Debian put in the work to build some tooling, and one of those tools is strip non-determinism. It's a tool that runs after the build and does fix-ups. Because Debian people realize that you can fix many things, but there's a whole class of things that apply to many packages, and fixing them in package one by one is just too much work. And we want to apply it to afterwards. And pretty much every distribution has ended up implementing something similar, but depending on circumstances, those are independent implementations. In particular, the Debian one is in Perl, and in Fedora we don't like Perl that much. So we have one in Rust called @determinism, more positive. And nowadays, like since a year and a half, it runs in every package build. So of course it's packaged, and just it does the various fixes that apply to multiple types of packages. We'll show examples later. Yes, so let me go through some examples. This is more to give an idea than to exhaust the problem space. So one thing that happens very commonly is that when you build static archives, a static archive is a format called AR archive, not used for anything except static archives nowadays. That contains a bunch of compiled object files with the .o extension. So when such archives are being built on the system, they embed metadata of the object files as they were in the file system during the build. So timestamps, user ownership, group ownership, and mode gets embedded in the metadata in the archive. And this means that when we repeat a build, the timestamps change and the ownership also changes usually. You can see in this example, I was building this test archive as my user number 1000 on the machine, and in the build system I might have a mock user with some different number, and then the archives would differ. So what add determinism does, and also what strip non-determinism does in exactly the same way, is to go into the archive and just wipe those bits that we don't care about, and then we have reproducible static archives. And this applies to, like, I don't know, 1,000 packages in the system, and doing it manually in each package would be annoying work and not efficient. So we do it this way. Another example is Java doc files. There's also thousands of those packages with tens of thousands of documentation files, and the timestamp is embedded in every header. And in principle, we could go into every package build system and like modify the AND configuration or the Maven configuration to pass some specific parameter to not write this header, but it's per package work, and it's just easier to do it after the fact and strip those headers. Okay, so those are two examples of things that we fix with add determinism. We also have other problems. So an interesting problem that we encounter is that when we build packages, and we first build this source RPM package, and then from the source RPM package, we build the binary packages for all architectures. So the source RPM package is built on one architecture, and then just copied over to, we just take one out of the whole subset of architectures that we support, and this is more or less random which one we pick. And the list of build requires that is embedded in this generated source RPM depends on the architecture. And when we try to do the rebuild later, we get a slightly different set. And one solution would be to ignore the problem and say that this doesn't matter, but we would like to make those builds architecture independent, and we can do that by changing the system we have at the top, where we write lines that will be evaluated at build time of the source RPM, into the system at the bottom, where we write lines that are that don't get evaluated at package build time, but get evaluated at package use time, so dynamically later. So we have build requires that are architecture independent, and we can also use the same scheme to have requires, which are architecture independent. And this fixes our problem with irreproducible source RPMs. But for the distribution, this would also be good, because then it means that you can query the dependencies for all architectures on a single architecture. So like you want to ask, where is Antler 4 used? Right now you have to repeat this query for source RPMs and then for each architecture independently, and then summarize the results. With this system, the build dependencies would remain separate, but the runtime dependencies would be displayed. You could just get a single answer from DNF repo query. But this is there is no disagreement with that, but this is still planned work, so this is not done. So I wanted to say what has changed in add determinism in the last year. So since a year and a half, it is applied everywhere, but we extended the functionality. So we have a new handler for zip files, and it is new because we already had a handler for jar files. And this is always the same story, that we have an archive, and the archive has metadata inside, and we need to strip the metadata. So for zip files, for gzip files, the very interesting thing that I worked on has been the PYC handler. So Python bytecode files are, depending on some, possibly the architecture or the phase of the moon, they are not entirely reproducible. And one thing that was known for a long time was the fact that there will be something called unused reference flags. So the PYC file is a stream of objects, and you can flag an object earlier in the stream with a flag, and then afterwards in the stream you can, instead of writing the object again if it would be the same, you can put a reference to the previous flag that occurred previously. And what Python was known to do was to set a flag and then not use it ever again. And then sometimes it would, like those unused flags would vary between builds. And then after we fixed that issue, which affected thousands of Python packages, we realized that there is another issue, that sometimes Python could replace an object by a reference to a previously written flagged object, and sometimes it does it for some reasons. And then when you do that, you can actually shrink the files a little bit and also make them reproducible. Support for Python 3.14, right? Because Python 3.14 is happening right now. Actually, the mass rebuild for Python 3.13 in Fedora has finished a few days ago. So the last couple hundred of packages are being fixed. And we also added a printer for PYC files, and this is something that can be shown. So, like after looking at PYC files for a few weeks, I realized that the existing printers are not good enough, and I wrote my own. So, if you care about this format, then well, it exists. The functionality exists. And right, I continue. Go.
I mean, either. So thanks to this progress, we put up a change proposal for Fedora 43, which has been accepted. And the idea is to start enforcing that we would like package builds to be reproducible. And the plan is to do this in steps. So right now, the expectation is that packages should be reproducible. We have infrastructure in place. We can do builds of the packages. We will show results where there are reproducibility failures. And then the expectation is that maintainers will have the information they need to be able to fix their packages. And at some point, we will put in place some infrastructure to automatically file bugs for people. We don't have that right now. Right now, this is a manual process. But the goal is to end up with no fewer than 99% packages reproducible in the distribution.
And to get there, we will use Rebuilder-D. So Rebuilder-D was created on so the Reproducible Builds organization. They also host an yearly summit, or usually yearly. And with one of the summits, a friend of mine, a KPC, where he started making this Rust program, and it's a service to aim to continuously rebuild packages, or basically any binary artifact. And since then, this has grown, so it supports Arch, Debian, Tails, and Fedora. It's written in Rust, of course. And it works by getting the repository metadata. So this in Fedora's part, this is like repodata.xml, and in Arch, it's like the package database. It fetches all the package information and the URL where the package is, and then dumps it in the database, and then it can schedule. It has its own job scheduler. It has workers. So maybe next slide. So this is the architecture. So there's one rebuilder on the right. That's the Rebuilder-D. That's the daemon. Then there's Rebuilder sync. This is basically a timer which just fetches the new latest package data, puts it in the database, and then workers can pick a package from the queue, and they will use any rebuilding tool required for the distribution. So for Fedora, that's Koji rebuilt, which, and it rebuilds the package, compares it, and then posts the results. It optionally can make a diffoscope output, and the workers can basically live anywhere. It just connects over to HTTP. That makes sense. And yeah, since now there are like multiple instances, so Debian has one. Well, it has multiple, one per architecture, and I believe they are now 92% reproducible, and the 89% is they have two, that's their CI infrastructure, which just does main package rebuilds twice. Arsenix has been doing this, I think, for 5 years, and we have also multiple instances, so there's some people who voluntarily run a rebuilder, and you can then also compare, like, if there's differences between rebuild packages between instances. That would be very interesting. There's a Fedora one now, unofficially, and there's also this fun script which works in Arch, and there's also a Debian version where you can run Arch repo status, and then it tells you how reproducible your system is. So if you're paranoid enough, you can fix the rest of the packages. Yeah, and I've been working the last few months to getting these rebuilder to package. This is almost done, so I only need to package the rebuildability package itself. All the other crates are done, and this should be available in Rawhide soon. And then we still need to package the Fedora-specific rebuild tool, which will hopefully happen soon. And then you might be able to run your own rebuilder if you want to. So the current demo environment, which I self-host, it excludes a bunch of expensive packages because, like, I don't have a very fancy machine. So, like, compiling Rust crates or GCC or LVM or Wacom, this takes a lot of disk space and CPU power. So you can exclude this from getting. So Rebuilder has like an exclude list, so you can say I only care about that NeoVim is reproducible, and I run my own Rebuilder D, and I only rebuild NeoVim on my own hardware. And yeah, so this is only a small sample set. So the next slide has the sad status, but this is it is sad because of because of infrastructure failures. This is not like an accurate representation. I think now it's up to 50%, but I ran out of disk space on the worker, and I had some other issues. So this is all work in progress, but yeah, there should be something soon. Yes. Live.
Yes. So we have Rebuilder D on one side, and this is where we want to go, but there's also like independent rebuilds done by me, and so I'll talk about the results. So this is not a statistically significant sample because it's just a random rebuild of things that just happened in a given time frame, like the last 2 weeks before I did this. But it gives you an idea. So I mean, 3,700 builds. And fully reproducible, we get about 85%. Another 6% is source metadata. So this is the stuff I talked about with build requires. So in a way, it's something that I mean, it's not that important. If we add those two numbers, then we get something above 90%. Yeah, so there's like a long list of issues. And we still have classes of issues that affect multiple packages. That is why one of the reasons why we are not really filing bugs against individual packages yet, because it doesn't make sense to bother maintainers if we haven't really solved the full set of issues that affect. I mean, they should be solved at the distribution level. So like the source metadata stuff or some stuff in compilers and so on. Yeah. So we keep a list of issues. I will not go through them. There is a link at the top if you want to do some deep reading. Some of them are very simple, just like a timestamp embedded somewhere, and some are kind of deep, like the first one that is at the top was required changes in GDB and GCC. So we keep a list, and like stuff that applies to multiple packages is usually tracked there. And I mean, there is still a bunch of those issues open. I don't know, like an example of an easy issue, this affects about 100 packages. Qt module metadata embeds a version of the build kernel. Why? Who knows? But and this is, I mean, this is to be fixed in the tool chain, right? And then the issue goes away. I know this is something that affects a single package. It again stores the kernel version. This was a fun one in my own package. And I wanted to mention that all those issues were found using rebuilder-d. This one also. When Jelle reported this, I thought this must be some mistake, some bug in RPM. But it turns out that the systemd package does actually sometimes create a symlink and sometimes not create a symlink in the package content. And this has been going on for years, and nobody ever reported this or noticed. And the issue is that systemd auto-generates a list, and there's a script to assign like ghost attribute to files in the list. And I made a mistake in this script, and the script is written in Python, and it checks if a file should be marked as ghost. And if there was a directory, it would sometimes apply the ghost attribute and sometimes not. Sorry, not a directory, a symlink to a directory, depending on whether the target directory of the symlink was reported as 0 size or not. So this was a file system dependent thing, and I mean a bug that is actually fixed using, well, following the reproducible builds procedure. Yes, and.
Oh yeah, we had some extra additional benefit that we found through this work. It turns out that there are other use cases besides the distribution itself where reproducible builds are useful. You should talk about this though.
So, like kind of independently, the idea to reproducible builds arose in for the trusted environment firmware, I don't know, system that you use on a CPU. Intel builds this, and they wanted to sign it only with their key. And there was this idea that we would rebuild it independently in Fedora, and because the build is supposed to be reproducible, it would get the same result, so that we could prove that the stuff that we are running is actually corresponds properly to the sources that Intel said that it corresponds to. We didn't end up doing this because they compile with old Ubuntu versions of the compiler and stuff like that, so we don't want to go in that direction, but in theory it would be possible. And also in various embedded systems and certified environments, people are working on build reproducibility because they want to assure quality.
Yes.
And this quote at the bottom is it was a funny story from at Determinism, where I got a pull request to add support for macOS resource files, and I was a bit surprised. And the answer is that people are working on a Java build system called Mill, and they wanted to work on macOS, so like open source at its best.
Yeah. Coming up, as Jelle mentioned, we will have Rebuilder-D in Fedora soon. Package review is expected any minute. We're also looking at doing another deployment of Rebuilder-D on AWS. We already have an account sponsored by Meta that has been used for the rebuild work that Zbigniew has been doing. And the idea is to extend that with a full Rebuilder-D deployment that hopefully should address the current resource limitations, because AWS has all the resources. So that will make that easier, and hopefully we can get a full continuous rebuild of the distribution. And then maybe down the road also have additional independently managed Rebuilder-D instances from various parties so we can compare results. We also need to package Fedora ReproBuild, which is the tool that's used for your rebuild work, and switch to hermetic builds using Mock. Oh yeah,
Yeah, so there's like some interesting Rust work to be done in at determinism, because I wrote my own message passing algorithm and it works nicely, except when you have too many CPUs and it deadlocks. So.
Yeah, and as we mentioned, we will have automation to file bugs to packagers once we've addressed most of the common issues, so we won't spam packagers, because we really want this to be set up in a way that the issues we file are actionable for people, so they don't get bothered by it. And finally, once we're done with Fedora, we will likely start looking at extending this to CentOS Stream, because it seems like a reasonable next path forward there. I believe that's all we had. These are links where you can find us, documentation, the link to the changes we mentioned, the tooling, and a previous talk. And I think we have a few minutes for questions. Yes. Okay. The question was whether we have looked at Cargovat and the results that are produced by Cargovat, and whether we could leverage this information here and compare results. Do you know about this?
Well, so Rebuilder-D does have support to add like a signature if the build is green, like if it's reproducible. But there's not really. So I know there's some people who have like a Pacman plugin which first queries the reproducible Rebuilder-B instance and then like warns you if you're installing any reproducible stuff. But I don't think has been any organizations yet. Like nothing of that has happened yet.
Yeah, I think in general. One nice thing about this setup is that because you can have multiple hosted Rebuilder-D instances, you can actually choose which ones you want to trust, and you can compare the results. And obviously, if the results match, things are fine. But if there are discrepancies, that can give you an idea of where to investigate. But yeah, I agree. I think integrating this in the package manager at some point would be nice, so people can get a warning. Other questions?
There was a question behind. There was like a blue shirt. I would do it for all packages. So the question is whether the normalization of requires to make them architecture independent, whether it would apply to no arch packages or to all packages. I would apply it across the board as a standard. But this is a significant change in the distribution, so I don't know. Maybe in the first part it will be just in some limited scope. Yes, glibc dependencies are architecture specific and it's going to be an uphill battle was the comment. Yes, that's probably true.
Anything else? In the front? The tool versioning.
So this is always, so the question was, how do we deal with tool versioning, and if one build requires one version and another build requires another version? So this is, the build reproducibility is always within the scope of having the exact same version of all tools. Also no other tools and no fewer tools, right? We create the build environment to contain the exact same package set with the same versions, and then we hope to get the build reproducible. If you change the compiler, then the build will be different always, and pretty much always.
Let me rephrase the question. So you have now Fedora 43, right? And if you want to rebuild Fedora 42, then you need different build environment for that to reproduce the exact same build. So the virtual version, like G16, for example, for 42, is it different than for Fedora 43, and how do you deal with it?
Right. So the question was, if we want to rebuild, Fedora is at Fedora 43 now, and we want to rebuild Fedora 41, do we need a different version of the environment? And the answer is yes. What we do is so Koji is the Fedora build system, and we query Koji, and it gives us a list of packages that were used in the build root for a given package build, and download those exact versions of the packages and create a build environment, so a build container, because the builds are actually done in a kind of a container with specific package versions. And those versions, they don't even change between versions, they change all the time. Like I do a build now and I do build in half an hour, I will probably have some packages already changed. This is a constant churn. So yeah.
Time for more. I don't think there's any advantage from running on the same system. The question was is there any benefit to running Rebuild.d on the same infrastructure that's doing the actual release builds versus on a separate infrastructure? I don't believe there's any meaningful benefit from running on the same infrastructure. I think there's probably benefits from not doing that, because then you can prove that you can reproduce the same results on a wholly separate air-gapped environment. Yeah, I don't think there would be even efficiency benefits from using the same one at the end of the day. Yeah. Yes?
I don't know if you would know example for archive files. I noticed that there is a timestamp that was 1 minute and 15 seconds after midnight and 53 versus 70. That seems a little interesting. Is something want to explain?
Yes, find the slide. The question was that there was a timestamp in one example that was very specific because it was right after the epoch. I think it was this one. Yeah, the 151. That's interesting. Maybe it's the time, like the build starts at epoch and it's how long the build took or something. Do you happen to know? I have no idea. That is true, yes. Yeah. Yeah, I have no idea.
That is very strange, yes. I mean, the 1 hour, it's fine, right? Because maybe the time zone, but the 51 seconds, I know it's very strange.
Yeah.
51 minutes. Yeah.
Yeah, no idea, sorry. Any other questions? I think we're good. Thank you very much.